Welcome to the world of statistical analysis, where every conclusion comes with a margin of error. No matter how meticulously you design your experiments and how carefully you gather data, there is always a chance of making errors. In this video, we'll take you through the different types of errors in statistics, with a focus on hypothesis testing, and provide real-life examples to illustrate each concept. First, let's talk about errors in statistics. In general, there are two types of errors, type 1 and type 2 errors. A type 1 error, also known as a false positive, occurs when we reject the null hypothesis when it's actually true. On the other hand, a type 2 error, also known as a false negative, occurs when we accept the null hypothesis when it's actually false. Moving on to errors in hypothesis testing, we can see that type 1 and type 2 errors can still occur. A type 1 error in hypothesis testing occurs when we reject the null hypothesis, even though it's actually true. This error is often referred to as a false positive. An example of this might be a clinical trial where a drug is declared effective, even though it has no real benefit. A type 2 error, on the other hand, occurs when we fail to reject the null hypothesis, even though it's actually false. This error is often referred to as a false negative. An example of this might be a medical test where a disease is not detected even though it's present in the patient. The question arises, which error is more dangerous? In many situations, it depends on the context. In some cases, a false positive, type 1 error, could have severe consequences. For example, in legal trials, it could lead to an innocent person being wrongly convicted. In other cases, a false negative, type 2 error, could be more dangerous. For example, in medical tests, a false negative could lead to the failure to detect a serious illness, which could then go untreated and become life-threatening. So, how can we control these errors? One way to minimize type 1 errors is by reducing the significance level, which means increasing the margin of error. Another way is to increase the sample size, which helps to increase the power of the test and reduce type 2 errors. In conclusion, while statistical analysis are an important tool for understanding and drawing conclusions from data, errors can still occur. By understanding the different types of errors and how to control them, we can increase the accuracy and reliability of our statistical analysis, ensuring that we make informed decisions based on solid data.